Get some new things. So length gives you the number of bytes, not the number of characters. So if we did length of that Chinese character, well, you can see that here. Right here's length of hello. It gives us 5. Let me make this full screen. So it's giving us the length of bytes, not the length of characters, because here we have 2 characters and the length is 6. Right? And so each character is made up of 3 bytes. So length gives us the length of the bytes, not the characters. Here we have slicing. So you could, here we are accessing by index, right? So greeting 0 is going to print out 72, and 72 is capital H. And greeting 4 will print out, greeting 4 prints out 0, 1, 2, 3, 4, 0. It prints out O, lowercase o, which is 111. 111. So that's accessing by index. So you could do that with a string. And that index access is, you'd see something like that with an array, but we know, hey, this is a slice of bytes, or array or slice, and this is a slice of bytes. And underneath the slice of bytes is an array, right? So a string is a pointer to a slice of bytes, and a slice is a pointer to an array. Interesting. What does this print? What is this going to print? But what will be the text that prints out? Okay, ready? So we have accessing by an index, like on lines 8 and 9. And then we have slicing. And the notation looks really similar. But the operators operate differently, right? And so slicing is, hey, I'm slicing up something. And I just want certain aspects of it. And so that notation right there says, give me from the beginning all the way up to, but not including 4, the person in position 4. And so here is 0, 1, 2, 3, 4, because it's a 0-based index. So it gives me everything from the beginning up to, but not including 4. So HELL, and we don't include the last thing, right? So that gives me, what the hell did that just do? And you could see some examples of slicing here. So there's that one where we got hell. And we could also include the 0, and that would give us hell. And we could say, oh, just from 1, and that gives us L. Or we could say from 1 all the way to the end, and that gives us hello. So it's slicing. And you can see the positions here. H is in 0 position, 0-based index. E is in the first position, which is actually the second position. That's the first position. It's kind of weird to talk about. But those are the indexes, 0-based index. So we could concatenate strings. Concatenation, we could do that with the plus sign, pretty straightforward. So here I have James Bond, 2 different variables, and concatenate them together with a space between them and print that out. There's concatenation, plus sign, pretty standard. And then you've got an exercise to do and exercises to do to practice all that. And then there's a string conversion package. I don't know how you say that. String conversion package. I'm going to say it like that. And the most common numeric conversions are A to I and I to A. So ASCII to int and int to ASCII, right? Taking int to a string or a string to an int. So some examples of string conversions. Like here, this first line is we have a string, which is the -42. That's a string. And I want to take that from ASCII and turn it into an int. And so that gives me I. And so I could then use that in a mathematical equation. Or I could take, and it also throws an error, just in case, no, I can't do that. Or I could take an int, right, and turn it into ASCII. How come there isn't an error here? Yeah, I think you could always take an int and turn it into ASCII, but you might not always be able to take, I don't know, some character that you put in here and turn it into an int. But an int can always become an ASCII, but an ASCII can't always become an int. So here's an example of, you know, I have an int, and so that's the wrong way to declare and initialize a variable. Right? I only want to use var when I'm declaring the variable and initializing it to a 0 value, so I'm not, you know, setting it to anything. And otherwise, I want to use shorthand notation. But I just wanted to emphasize, hey, that's an int. And so I've got an int, and I'm making it an ASCII, and so then I could concatenate it and, you know, hello world 5. Because it's a string, I can concatenate it. And here I have sprint. I could also, instead of, what was it, ASCII to int to ASCII. Instead of int to ASCII, ITOA. Instead of int to ASCII, I could use format sprint, and that will turn it into a string also. Just FYI. I have a little note down there that says, let's look up format sprint to see how it converts an int to a string. Do you guys want to do that? Sort of have a little bit of practice of like, hey, let's look at the documentation. So we go to godoc.org and we put in format, right, and brings us the format package, and then we have sprint. And I just had this sprint right there, that sprint. So I could click on that, and sprint will take empty interface, so that means any type, and variadic, and that parameter, so unlimited number of them. And I'm at sprint line. Where's just sprint? Same thing. And it returns a string. Oh, hey, so it takes any type and returns a string. That's cool. So just reading that from the signature. And sprint formats using the default formats for its operands and returns the resulting string. Spaces are added between operands when it's string. So I could click on, well, let's try clicking on this and see what happens. And here's a sprint in the code. So this is the source code, whatever, the library, the standard library. I'm starting to get some of these programming terms. And sprint, same thing we just read. But here it creates a new printer, P, and then it does print A, false, false, and then string pbuff. So I'm going to go back to WebStorm because I think I could do a little bit more clicking in WebStorm. And if I had format sprint, and I'm just going to put in a sprint here and pass in Y, but I'm going to click on that, and it takes me to the same thing here. But then I can also click on new printer. What's a new printer? And new printer, panicking, erroring, format int, printer, new printer. Where is that? Print.go. And compare with clipboard, refactor, find usages. I was looking to see if there's some way that takes me to show usages. Show usages. Just looking to see if there's some way I could come to the package. So sprint takes me to there, which new printer. So where is a new printer? New printer. Let's see if new printer is in the docs here. New printer. Nope. So I could try Golang new printer. But anyhow, I could start digging around source format print.go. And
it's not capitalized. That means it's private.
Yeah, it's private. It's not capitalized, so it's private. But I could start looking at that and like, hey, how's this stuff work? You know, and start figuring out how it turns it into a string. And I imagine somewhere we might, I don't know, maybe we'd see the string conversion, new printer, PPP. Anyhow, that's just a interesting thing to do. Look at how they've written their code. Do. All right, so there's sprint. Oh, hey, I actually do this here. Click the name of the func, and you're taken to the source code. This takes you to reading even more source code. What is a new printer? Does the conversion assertion occur in do print? So do print. I think that's a function. Is the conversion string pbuff? String pbuff. So we're taking pbuff and turning it into a string. Maybe that's it. These are good questions, and digging in the source code, trying to understand it, will build your skills and familiarity with the language. At a certain point, you say, okay, format sprint, we'll convert an int to string. So at a certain point, you just say, okay, it works, right? And so here we have an example of A to I, ASCII to int, and then using that in a mathematical equation. And then some exercises. So the next deal is conversions. We've already seen quite a bit of conversion, known as casting in some languages. And conversions are expressions of the form tx, where t is a type and x is an expression that can be converted to type t. So t is a type and x is an expression. So hey, they're saying a variable could be an expression, an int could be an expression, right? A float could be an expression. So, and we have some expression or variable, and then we just say, try to convert this to t. So, you know, that's what a conversion is. We've seen that. And so where did we see one? We saw it right here. I think I had a conversion in here, did I? Slice of bytes, right there, conversion. Right? Taking a string and converting it to a slice of bytes. Saying, this right here is a string, but underneath it, it's a slice of bytes, so I'm going to turn it into a slice of bytes. I'm going to convert it to a slice of bytes. And byte slice is understanding that thing about strings and byte slices. That's like, you're going to use byte slices a lot. So you can read conversion between numeric types and conversions to and from a string type. You know, just kind of like, okay, how do I understand docs? You can read that on your own. Which means that, wow, man, I didn't find a whole lot to pull out of that, but maybe it'd be interesting. But also good, just to kind of like see what you get out of it. So here we have an int and a float 64. Not the right way to declare variables, Mr. McLeod. Right, I should be using shorthand notation. And format print line, right? And what kind of conversion am I doing there? An int to a float 64, the comment tells you. So I'm taking my int, which is x, and converting it to float 64, and then I can add them together. So strictly typed. Strongly typed. And here's from a float 64 to an int. And here, we've learned that rune is an alias for int32. So on line 6, I'm saying, hey, you know, x is a rune and it's equal to a. And on 7, y is int32 and it's equal to b. And I could print each of those and I get the numeric representations of those characters. And I could say, you know, convert those numbers to a string. So there's another conversion. I'm converting those numbers to a string. Rune to string. I think I'm a little remedial. Maybe that's just a bad assessment, but you know, it's all relative, right? So I don't know if you've seen Idiocracy, right? Where the totally average dude is like genius level because they're just all Neanderthals or whatever. It's all relative. But rune threw me for a long time. I'm like, what the hell's a rune? Rune, it's an alias for int32. What's that mean, right? But like for like months, I kid you not, rune was like, I got to understand rune more. I still don't have my head around it. It's just a character. Why didn't they call it car? I don't know. Maybe there's some reason.
Maybe they didn't know how to always pronounce car. Some people say char, car.
Char, car.
Yeah.
And rune.
Everybody knows how to say rune.
Yeah. And rune is actually a really, you know, when you look up the definition of a rune, it's a character. You know, so it's the perfect word for it. But I'd never heard that before, so it was a foreign word for me. So my 44-year-old mind freaked out. Like, something new. What the heck's going on here, you young whippersnappers? So here we're taking a series of, what are those HELLOs? What would you say those are? HELLO. What type? What type is H? It's a rune. Sure, N32. I'm curious. So let's do another divider. And let's do another Z is, this will be weird. Z is H. And then format printf and %t and Z. And 32. It's a rune, right? And rune is just an alias for 32. So even if you define it as a rune, it's going to print in 32. So here we have a series of runes. And so that's actually a slice of bytes. So it's not conversion, slice of bytes, right? And each byte is 32. Int 32 means there's 32 zeros and ones there, which means it's 4 bytes. So H is 4 bytes. That's kind of interesting. Is that right? Because weren't we looking at H just being a single byte earlier? Just kind of curious, right? Like, when were we looking at, when we looked at a slice of bytes, we saw a byte for ASCII characters. But here we're saying that a slice of bytes, H is actually, right? If it's N32, would it be an N32 is stored there if it's a rune? But I think what that is like it has up to 32, up to 4 bytes. And that's why UTF-8 is up to 4 bytes. And we're just using 1 there. So that's just an interesting thing.
4 bytes?
Because rune is N32,
Yeah.
right? But when we were printing out our slice of bytes, we're getting 1 byte for F, correct?
Yeah.
So if 1 byte is 8 bits, but we're storing 8 bits in a variable N32, can we store just 70 as an N32? Yeah, we could store 70 as an N32, right? So I guess that's what's happening. And then converting our slice of bytes to a string. And here we're converting our string to a slice of bytes. So just being familiar with how these things go back and forth. Why is it that we can convert a string to a slice of bytes? Yeah. Like, what are the underlying internals? That's my new word after this weekend. What are the underlying internals that allow us to convert a string to a slice of bytes? What is a string? What is a string? Okay, so string series of characters, that's one definition. And size and representation, when we think about type, that's another one. And if we think about strings, it's like, okay, a slice had 3 words, right, in its header or definition or whatever. One is a pointer to an underlying array. Next is length, next is capacity. And then a string had a pointer to slice and then length. Those were the 2 words for the string, right? And the slice then on its own points to 3 things, right? Or has 3 things. But a string is a slice of bytes. So we could just look at that again here. String. Array of bytes. Oh, my bad. Array of bytes. Did I have that right? And second word is length of those bytes. Maybe I took those notes wrong. So let's go look at string. Golang spec. And we'll look at types. String literals. A string literal represents string constant obtained from concatenating a sequence of characters. There are 2 forms, raw string literals and interpreted string literals. So raw string literals are backticks. And I'm just going to look for bytes. So where's this stuff? Let's go look at Effective Go, see if they have anything about strings. Slices. Type switch, interface and other types, type assertions, string. I don't know. Where did I learn this? That it's a slice of bytes. Golang string slice of bytes. Strings, bytes, runes, and characters in Go, the Go blog. What is a string? In Go, a string is in effect a read-only slice of bytes. So the Golang blog is the official blog. So read-only slice of bytes. So that is incorrect here, that it's a pointer to an array of bytes, unless you're saying, hey, it's a slice of bytes, and then the slice of bytes points to an array of bytes, right? So that would be, I'm going to change this to slice. I forget what my point was. Slice of bytes? Yeah, why can we do that? Because a string is a slice of bytes, right? What would be the type if we just printed out, hey, give me the type of, quote, hello, that string literal, what would be the type of that? We said, show me the type of just hello. Yeah, I think so, string, right? So let's make this hello. String. And then if I did the slice of uint 8. About if I had Chinese characters in there. Still slice of uint 8. It's just the 3 byte slice of bytes. But if I have an individual character, int 32. Sorry, what happened? Int 32. So a couple exercises. So we have conversion, which changes one type to another, and then assertion, which is used for interfaces. And we'll learn more about interfaces. As you gain exposure to them, you'll gain understanding. So we already saw this. X is of type interface. Wow, this is a long presentation. So maybe we'll just take a pause here and pick up on assertion in a minute or next week. Let's see what else we've got going.